Hello students, today we're looking at 10.2 multiplying polynomials by monomials. Now today we are just essentially revisiting the distributive property. There's just going to be variables involved throughout. So if you guys recall the distributive property, we were seeing things like, actually we have the distributive property right here, we were seeing things like this, where you would have, for example, 2 times x minus 3. You would distribute that 2 multiplied by everything on the inside. You'd have 2x minus 6. You would go from there then, whether you were solving or combining like terms after that, whatever. So distributive property is happening again today, except you're going to be distributing monomials, which are going to have variable terms in them. Nothing changes as far as the actual steps we're taking. Okay, there's just some examples here that are already done for you. And then on these examples down below, we'll kind of walk through those together. So the actual steps you're taking to distribute are the same. We just have to be careful with what we're doing when we're multiplying with these variable terms. So this is going to kind of tie back into module 8 that we did last week, where we are going to be seeing the exponents of these variables change based on how many are being multiplied. So those rules are going to come back into play here. So when we're distributing, okay, first of all, we have to make sure that that term outside is being distributed to everything on the inside. So the first multiplication we're seeing is negative 2x times 4x squared, okay? Now what that's going to equal, your negative 2 times your 4 is going to be negative 8. You can always multiply those coefficients. And then this is technically x to the first, so when we have this x to the first times x squared, this is when we multiply powers that have the same base. What do you do with the exponents? You add them. So there's technically 3 x's there. We have negative 8x cubed. Because remember, when we saw this in module 8, we were seeing things like this. Negative 2 times x times 4 times x times x. We were looking at them broken up and split apart into each individual factor so we could kind of see where these numbers and exponents come from. You multiply together everything that will fit. So you can always multiply the constants together, negative 2 times 4 like we did to get negative 8. And then there's 1, 2, 3 total x's to get your exponent of 3. Now I'm not going to continue to do this process. Hopefully we recall that from module 8. We're going to focus now on the actual distributive portion of this and focus a little bit more in on what's happening today. So then that negative 2x times 3x, negative 2 times 3 is negative 6, x times another x is x squared. So we might be thinking, well, yesterday we just added the x's together. They didn't combine with their exponents. When you're adding and subtracting polynomials and monomials, the exponents are just there to show you the like terms. That coefficient tells you how many of those x's or x squareds you have, and you add them up. When we're multiplying them, we have to account for an x times another x, which will turn into x squared. So yes, it is different rules for adding and subtracting versus multiplying and dividing. Okay? And then that negative 2x times negative 5. So negative 2x times negative 5. There's no variable term with that negative 5. So we're just going to see a negative 2 times negative 5, which will equal positive 10. And then that x is coming along for the ride. It's just going to stay there. It's a part of what we're multiplying. It's just not going to change because there's only one x involved. And then you go ahead and you present this in standard form. So I've got my negative 8x cubed. I've got my negative 6x squared and my positive 10x, and you would be done here. Okay? So once you distribute that out, you're done there. The next one, excuse me, very similar. Okay? Negative 3x times 5x to the fifth. So we're seeing a little bit different exponents here. Negative 3x times 5x to the fifth. Negative 3 times a positive 5 is going to be negative 15. And then 1x times 5 more x's, there's going to be, remember we add these, 1 plus 5, there's 6 total x's being multiplied there. So we're going to have negative 15x to the 6th. That next one we see, negative 3x times a negative 3x squared. Negative 3 times a negative 3 is positive 9. X times x squared is going to be x cubed. There are 3 total x's there. And then the last multiplication we're doing in this problem, negative 3x times just a 7. And that's going to end up negative 3 times a positive 7 is negative 21, and there's just an x there along for the ride. And then again, we go ahead and put this into standard form, which if we recall from yesterday, was that biggest degree is first on through the next biggest until you got the smallest degree term at the end. So we have negative 15x to the 6th plus 9x cubed minus 21x. Okay? And this next slide is just going to be a little bit bigger problems where, remember, we want to get multiplication done before we subtract. So this is where if we had something along the lines of 3 times 5 minus 4 times 2. We need to make sure that we are doing those multiplication pieces first, right? So here we've got one multiplication. And we're subtracting a second multiplication. Now I would keep that negative sign as a part of your multiplication, because then you don't have to worry about any signs being crossed up after that. So if you distribute a negative 2 through that whole second expression, you're just going to end up with a whole long string of terms that you can just add or subtract based on like terms at the end. So let's kind of see what we're looking at here. So this first one, 3n times 6n cubed. 3n times 6n cubed is going to be 18n to the 4th, okay? And then 3n times a negative 4n. And that's going to end up with 3 times negative 4 is going to be negative 12, and n times n is n squared. Now in the blue, we've got negative 2 times 9n to the 4th. That's going to be negative 18n to the 4th. And then we end up with 2 times a negative 2 times a negative 11, which is going to be a positive 22 for you. Okay, so now we did all the distributing, all the multiplying is gone. Now you're going to go ahead and combine these like terms. You don't have to write these into an expression. You can combine them just as they are right now as separate terms. Or you can go ahead and rewrite it from left to right. So 18n to the 4th was the first multiplication. Negative 12n squared was the second one. Negative 18n to the 4th. And then plus 22. You can rewrite it as that and then combine them as they sit. Or you can combine them just out of this set of terms like we had there. Okay? Really, that's up to you. Oop, I'm moving the screen around there. I don't want to do that. Okay? So, what we see when we go to combine these like terms, I've got an 18n to the 4th, and that's going to combine with any other n to the 4th terms that I have. I'm looking at the matching variable and its exponent. It's going to match with a negative 18n to the 4th. Now what happens when we combine 18 and a negative 18? 18 minus 18 cancels out to 0. So these n to the 4th terms actually are gone. We have a positive 18 and a negative 18, n to the 4th, they cancel out. So there are no more n to the 4th terms. Okay? We technically have 0 n to the 4th. Well, 0 times anything, even a variable, is going to cancel out to be 0. Okay, so that is gone, and you don't have to account for that. You don't have to write that 0 down there. So now all we have left, I've got a negative 12n squared. Are there any other n squared terms? No, the only other term is a 22. So neither of those have any like terms to be combining with. So I have a negative 12n squared plus 22. And as long as you have no more like terms to combine, you are done. So one of our set of like terms canceled out, and the other two terms remaining were the only ones of that type. So that's it. We've got negative 12n squared plus 22, and we're done. Now let's go look at the next one. Let's kind of divide this so it's not too confusing when we start getting everything written down here. Okay, so with our multiplications here, we've got 2n squared times 5n cubed That's going to end up with 2 times 5 is 10. N squared times n to the third. There are 5 total n's there, so it's n to the fifth. And then I've got 2n squared times 6. So 2n squared times just a 6. The only thing it's going to multiply with is a coefficient, so it would be 12n squared. Sometimes we forget to include that n squared because 6 doesn't have one. Remember, if we were to break this all up as 2 times n times n times 6, we have to account for everything in that multiplication. It will stay as an n squared term. Okay. Then the next one, we got negative 5n times a 3n to the fourth. Negative 5 times a positive 3 is negative 15. And then a single n, remember, there technically is an exponent of 1, times n to the fourth. There are 5 total n's there, n to the fifth. And negative 5n times 3n squared. Negative 5 times a positive 3 is going to be negative 15. And then n to the first times n to the second is n cubed at the end. Okay? So right now, our 4 terms, we've got 10n to the fifth plus 12n squared minus 15n to the fifth minus 15n to the third. So first things first, are there any like terms that we need to be combining? I only see one pair of like terms, and that's going to be this 10n to the fifth and then negative 15n to the fifth. Once you've identified like terms, it's going to be some n to the fifth term at the end of that. And then 10 minus 15 is all you have to worry about combining. 10 minus 15 is going to be negative 5. I end up with negative 5n to the fifth. That n to the fifth is the type of term. That doesn't change. Okay? And then my positive 12n squared does not have a like term to combine with, and my negative 15n to the third does not have a like term to combine with. So those are my 3 remaining terms. I don't have anything to combine any of them with, so I'm done simplifying. Just make sure that you're in standard form. That negative 5 n to the fifth has the biggest exponent, so it has to be first. Negative 15 n to the third is the next biggest exponent, so that's got to be next. And then positive 12n squared is the smallest exponent, so it's last. When you put it in standard form, you put it in order of biggest degree to smallest degree. Remember, we're only looking at the exponent, looking at the degree. The coefficient, that number out front, has nothing to do with the order of how they're going to be placed in their final expression.